Objects in the Pitt Rivers Museum collection are researched and used by originating communities to reconnect with their heritage. For musical instruments, ideally this process could involve playing them. However, there are many dangers to both the instrument and the player in doing this. Introducing moisture to a dry, fragile flute made of wood, ivory or bone could cause damage to the instrument, whilst the use of pesticides, such as mercury and arsenic, used by museums in the past, could cause harm to the player. We wanted to find a way to make our music collections more accessible using the latest in 3D scanning and printing technologies. We needed a playable instrument similar to those in the museum collection. We chose a 17th century ivory recorder made by Goddard of London, one of the many playable instruments in the Bate collection. To replicate the recorder as closely as possible, we used a CT scanner which uses X-rays to give a 3D map of both the external and internal surfaces of the instrument. This is just like a medical CT scanner, except that the object moves whilst the X-ray source remains stationary. It's also much higher resolution, so we can record more detail.
The CT scan's now running, and so each time the green line goes across the screen is when it's taken another radiograph, and then the software will reconstruct that to give you the internal detail and the volume of the object itself.
The ivory recorder is cracked and damaged in various places. It would have been possible to digitally clean up the scan data to repair the damage and create a perfect instrument, but we wanted to produce a replica with all of these same faults. Otherwise, how could we compare the 3D printed instrument accurately with the original?
So if you look at that plane, that's showing you where we are in the other images. So that's that hole there. So you can see it's done a definite upright angle there.
There are lots of different methods and materials for 3D printing, so we chose resins that we thought would be similar to ivory to print 5 replicas using 3 different techniques.
This is one of our 3D printers. It's called a multi-jet printer, and it works using inkjet printing technology. To print the mouthpiece and the block, it's going to take about 5 hours. So it's very quick to load the files into the printer. The tricky part is getting the model to print from. So in this case, we were working from a 3D scan. And then when it's printed, we can take the parts off the bed of the machine, put them in the oven to melt the wax, and then we're left with the completed printed part. Probably one of the most tricky parts was resolving the 2 details here. So we've got the labium here, and then we've got the mouthpiece block here. They're the surfaces that really make the voice of the recorder. So it's important to get that part right.
What's the strangest thing you printed?
A recorder.
At a public event in the museum, a recorder player played the original ivory recorder and each replica in turn, and the public voted on which they thought sounded most like the original. There was a clear difference in the sound of all of them, so the resin you use does make a difference. A professional recorder player, Fatima Laham, carried out another assessment of the replicas from a player's point of view. We invited colleagues from the university's music faculty and engineering science department to discuss the replicas and hear a wide range of opinions on the instruments.
And what we're studying is, so now let's think of in a very scientific point of view, we have a block of material A, block material B, block material C. How do they perform individually?
Yeah, to me that's no comparison.
So that's why I was interested to know whether you meant that is the mouthpiece the one making the difference, or is it the whole thing making a difference?
That would be a really interesting way to extend it, because this, I think, would play very differently with a different block in.
I think it is already a very good result that these two can play together. I'm keeping a musical instrument on the under a glass window in a museum. There is no use for the public. By making reproduction, we hope to let people learn and the sound of the old instruments.
We're hoping to scan and print a bone or ivory instrument from the Pitt Rivers collection, using the resin that we've identified as being the most accurate, and to work with the source community to see if this technology could unlock the sound of the instruments which has been silent for so long.